Okay, you've been able to identify y-intercepts, x-intercepts, an axis of symmetry, a minimum or maximum value, a vertex coordinate, all from a picture of a parabola. But all those parabolas came from equations. They all came from equations that had an x squared or whatever variable squared. They were quadratic equations. Now we're going to do all of the stuff we did before, but we're going to do it from just the equation, not from the graph. So every single piece of the equation and every single characteristic we identified has a way to get it. We're going to go through them. This is really important. You're probably going to have to go back and watch this again. The first and easiest one is the y-intercept. The y-intercept is a c value. Remember the formula, or the form, sorry, the standard form is a x squared plus b x plus c. Also remember that this plus and this plus could very easily be a minus and a minus. It could be a plus or a minus, it doesn't matter. So the a, b, and c we're talking about are these numbers. So the c value, this value, is the y-intercept. Okay, that's easy enough. I can find that just by looking at it. The axis of symmetry, that symmetrical line, that vertical line that goes along an x, it's an x equals line, has an equation to find it. That equation is x equals negative b over 2a. That is a negative, not part of a fraction bar that's broken up. It equals negative b over 2a. So we're going to take this number, put them into this formula, and calculate the axis of symmetry. All right? Then we're going to be able to find either the minimum or maximum value, that y value, by taking whatever we got for x, whatever we got here for x, we're going to put that back into this original equation. We're going to solve it out because it's going to be y equals, or f of x equals, either or. We're going to solve it for y by putting the x value back in. Whatever we get for y, that's our y value for the minimum or maximum. Now, it's a minimum if the a value is positive, because that means the parabola will open upward. And it's a maximum if the a value is negative. That means the parabola will open downward. And then we'll take that x value we got here and the y value we got here, we'll put them together, and we'll create a vertex coordinate. And then last but not least, those x-intercepts. The x-intercepts are what we did in the last chapter. When we solved all these equations, we got values for x. Well, the values we got for x are x-intercepts on the graph. So all that solving equations is to tell us where we intercept the x-axis in our parabolas. Take a look and see how it works out. Y equals x squared plus 6x minus 16. The a value is positive. Therefore, my parabola is going to open upward. Which means if it opens upward, it has a bottom. It's going to have a minimum value. But I don't know that minimum value yet, so I'm going to leave this blank for now. I'm going to have to fill this in a few minutes. The y-intercept is just the c value. The c value is negative 16. So the y-intercept is negative 16. The x-intercepts we won't know until we solve it. I'm going to do that last. I'm going to find the axis of symmetry next. So I'm going to use that formula that was given above, which is the axis of symmetry is x is equal to, I like to put the negative in numerator on the b, not on the whole fraction. Negative b over 2a. So this is the a is 1, b is positive 6. So if I put positive 6 in here for b, I will get x is equal to negative 6 over 2 times a. Well, 2 times 1 is just 2. Now let's divide that, simplify it, whatever you can do. X is equal to negative 3. So the axis of symmetry will be at x is equal to negative 3. That'll be my vertical line that goes and splits my parabola right down the middle. Now I have a value for x. I'm going to put it back into this equation. I'm going to solve it to get y. So I'm going to have negative 3 squared. Well, be careful. Anytime you square a negative, it's always a positive because a negative times a negative, it's always a positive. So I'm going to do this step immediately in my head. I'm not even going to put negative 3 squared. I'm just going to put 9. So y is equal to 9 plus 6 times negative 3. That's actually negative 18. And then minus 16 according to my equation. So 9 minus 18 is negative 9. And negative 9 minus 16 gives me a value of y is equal to negative 25. That's pretty far down there. You're not going to see that on most of our graphs we're looking at. So that means that my minimum value is y equals negative 25. Okay? And now I can take this axis of symmetry x, my minimum in this case value of y, and put them together to create the vertex point of negative 3, comma, negative 25. And last but not least, I need to get my x-intercepts. I need to take this equation and factor it to solve it using my zero product property. So let's see. I have this. I'm going to get rid of this 1 just so it doesn't confuse me. X squared plus 6x minus 16. Any factors of 16 that subtract to make 6. Well, that would be 8 and 2. So I'm going to get 2 sets of parentheses. I got an x and an x. I got an 8 and a 2. 8 times 2 is 16. 8 minus 2 is 6. My signs are going to be different from each other. And the larger sign will be the positive. The larger number will be the positive. So the 8 gets the positive. And the 2 gets the negative. And then I'll solve each of these two parentheses using the zero product property. So if x plus 8 equals 0, x is equal to negative 8. And if x minus 2 is 0, x is equal to 2. That means I'm going to intercept the x-axis at negative 8 and 2. Ta-da! We have ourselves all the information. Do it a couple more times. Y equals x squared minus 8x plus 12. First of all, the a value is positive 1. So because the a is positive, it's going to be an upward opening parabola. That means my parabola opening upward, the U shape, is going to have a bottom or minimum value. I don't know that minimum value yet. I'll calculate that eventually. My y-intercept is just my c value. C value is positive 12. Y-intercept is 12. X-intercepts, I don't know yet. I'll calculate that when I solve it. I'll do axis of symmetry first. So my axis of symmetry is x is equal to negative b over 2a. You're going to need to memorize that formula. You're going to use it enough. Eventually, you're going to just know it. So in this case, b is already negative. So if I have a negative b, that's going to get me a positive 8 over 2 times a. A is 1, so that's 2. That means that my axis of symmetry is x is equal to 4. Ta-da. Now that means I already have half of my vertex, so I'm going to fill that in right now. 4, comma, I'll find the y. I'll find the y by taking this 4 and putting it back into this equation and solving it out. So 4 squared, so y will equal 4 squared, which is 16. Negative 8 times 4 is negative 32. And then plus 12. So that means that y will equal, well, 16 minus 32 is negative 16. Negative 16 plus 12 is negative 4. So my minimum value is y is equal to negative 4. And that's the other half of my vertex. And my final step is to find the x-intercepts. Let's solve this equation by factoring. Any factors of 12 that add to make 8? Well, let's see, 4 and 3, 4 plus 3 is 7. Nope. 2 and 6, 2 plus 6, 8. Got it. So I got my two parentheses. I got an x and an x. I said my two factors were 2 and 6. Both of my signs are the same. They're both negatives. And then I'll solve each parentheses using that zero product property. If x minus 2 is 0, x equals 2. And if x minus 6 is 0, x equals 6. So my two x-intercepts are 2 and 6. Okay, one more special case here. First of all, I take a look at this and I see a negative a value. Negative a value means it's going to open downward. It's going to be a downward facing parabola. That means it's going to have a top and point downward, so it's going to have a maximum value. Don't know that maximum value yet. I'll figure it out in a minute. Take a look at this. This is the A. This is the C. So the C tells me y-intercept is 9. There is no B. There's no B value here. So since there's no B value, if I do x is equal to negative B over 2 times A, there's no B value. That means that B is 0. So negative, well, there's no such thing as negative 0, so it's just 0 over anything means that my x, for my axis symmetry, my x is going to be 0. Vertex is already 0, comma, something. All right, let's take that 0 and put it back in. 0 squared is 0. No such thing as negative 0. That means that y is equal to 0 plus 9. Yeah, y equals 9. Y equals 9 is my maximum. And that means that's the other half of my vertex. And the reason that number comes up again is because if the axis of symmetry is x equals 0, that means that you don't move left or right on the axis. That means you stay right at the origin, and the y-axis is actually the symmetry line. If the y-axis is the symmetry line, that's part of my vertex, so that means that my y-intercept is my vertex. If you can picture that, it makes perfect sense. My last step is to solve to get the x-intercepts. Well, I don't like a negative x squared, so I'm going to factor out a negative 1 first. If I do that, I get a positive x squared and then minus 9. And hey, check it out, I got a difference of squares. My difference of squares, factor the x squared, x and x. Square root of 9 is 3, and 3. 1's a plus, 1's a minus. I'll bring down that negative 1 GCF, but remember, if there's no variable there, when I solve my zero product property, this becomes extraneous, irrelevant to the answer. And I don't have to solve both of these because they're going to be opposites. X plus 3 is 0. X equals negative 3. Oh, let me try that again. X equals negative 3. And x minus 3 is 0. X is equal to positive 3. So my x-intercepts are at negative 3 and positive 3, which also makes sense because they're equally distant from that axis of symmetry, which is 0. They're both halfway on either side. That's how we do it. Let's see if you can apply it.